I hope my presentation is visible to all.
Yes, yes, yes,
Yeah,
very much.
thank you very much. Today I'm going to talk about a totally different topic. And yes, because we have been asked to talk about the functional coatings, I think this is the EN 10289 field joint coating is one of the uh, very new and a very hot topic at this moment of time. And I will take this opportunity to uh, give some light onto the one of the very important field joint coatings, which is mostly suitable for most type of pipeline, let it be buried, let it be above ground pipeline, and for that matter, EN 10289 is one of the very important specification that one should look in and should give you the maximum benefit. So let's understand in detail what uh, ISO EN 10289 is a specification for the steel tubes and fittings for onshore and offshore pipelines. This is specifically talking about the external liquid applied epoxy and epoxy modified coatings. It's an English version of DIN EN 10289 2004, and it is specifically talking about the pipeline external field joint coatings. Okay, when we want to talk about it, is having the three different types, that is type 1, type 2, and type 3. This type 1 coatings are up to suitable up to the 40 degree C, from minus 20 degrees C to 40 degrees C. Uh, the next type 2 is minus 20 degrees C to 60 degrees C. And last but not the least, that is type 3, which is from 20 degrees C to 80 degrees C of the temperature. This is the design temperature as well as the actual temperature or the service temperature. And these are in class A, B, and C. What this class A, B, C says? The class A calls for the coating thickness up to 400 microns. Class B calls for 800 microns, and class C calls for 1500 microns. The most critical parameter here is the hardness of the coating, which should be minimum 80 at that class. You can get the hardness of say 80 at 250 microns, but that is not acceptable. It is talking about getting the hardness, the surety hardness of minimum 80 at 1500 microns or 800 microns or 400 microns whenever the coating is applicable to class A, B, or C. Now, this is one of the very critical parameter. The another parameter is the holiday test. As a rule of thumb, in normal circumstances, as a rule of thumb, it is said that whenever you go for application of holiday detection for any protective coating that is applied onto the surface, it is 4 volts per micron. But in EN 10289, the holiday detection test has to be carried at 8 volts per micron, which is absolutely very high. Now, another critical parameter is the cathodic disbondment test, which is to be carried out at the service temperature. It is not only at room temperature, but also at the service temperature. As I already discussed, high voltage holiday detection at 8 volts per micron. The thermal aging, which is a great thermal aging cycle at 100 degree plus or minus 2 degrees centigrade, it is for 100 days. The electrical insulation where they are talking about the surface resistance, which should be always greater than 10 raised to 4 ohms per square centimeter, which is very, very high. It is talking about the indentation requirement, which should be less than 30%. Again, it is at the service temperature, it is not at the room temperature. At service temperature, the indentation should be less than 30%, which is very, 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 very crucial requirement. The impact resistance is again more than 5 joules. Now, if you look at all those test parameters, the coating which you should design should meet all these requirements, which clearly shows that it needs a very, very high degree of electrical insulations. It also shows that it should have a very, very high degree of adhesion to the surface. Okay, it should also have a specific electrical insulation, which are the most critical parameters as of any coating, any protective coating is concerned. That's the reason not the all mastics, not the all solventless epoxies, not the all types of glass fic filled coatings can work in this particular specification. You have to design a coating system which meets to the specification of BSEN 10289. So where it is used onto the field joints. Now, whenever you look at a factory coated pipeline, you will see that it will be having either FBE plus 3 LPE. So taking in, they will be taking in the, they will be taking in the FBE out of the coated 3 LPE. Now, this is known as the FBE toe. This FBE toe, it should not get disturbed. The coating should have the adhesion onto the FBE as well as onto the blasted, the exposed area. So how the coating should be? Coating should be like this. Means if you consider that this is the pipeline, this is the FBE toe, adhesive and the topmost polyethylene tape, then the liquid epoxy should be able to get applied, which should be a junction between PLP, FB, and the base metal, which is again one of the very, very critical requirement. And to meet this, you have to design a coating system in accordance with EN 10289. Now, this is the summary of the required properties, which talks about the dry film thickness, which talks about the surety hardness, which talks about the appearance, which talks about the adhesion onto the cutbacks, which talks about the impact resistance, which uh, adhesion pull-off test requirements, cathodic dissolvent test requirements. These are all given into BSEN 10289. So, how do we say that this particular coating works onto the system? So we develop a coating system as Pentazone 1000 BSEN 10. We gave this particular name BSEN 10289 to our product Pentazone 1000. This is for the ease of understanding. Now, this product can be applied by single leg airless spray, pleural component airless spray from the thickness requirements of 400 microns to 1500 microns. Now, as you will see that the whole pipeline here is coated with Pentazone 1000 BSEN 10289. Now, in this case, the thickness requirement was minimum 800 microns. So Pentazone 1000 BSEN 10289 is uh, giving the service as per the type 2 class B. Okay, so in this case, if you could see here that it is applied by brush onto the hand tool prepared surface. This is the classic example. It is hand tool prepared surface and it is being applied by brush at the thickness of 1500 microns. To achieve the coating thickness of 1500 microns, it takes hardly 20 to 25 minutes of brushing without stopping in between. You can build a thickness of about 1500 microns. And once you build it, you can see it. It is very easily achieving the thickness and achieving the surface finish. Now, when you apply this particular coating, you have to undergo a critical test, which is also known as a holiday detection test. Now, this holiday detection test is carried out at 15,000 volts, 15 kV. This is the specific requirement of coating which is applied at this particular thickness on the pipeline which is supposed to get protected when it is buried. Now, this particular material, pentazone 1000 BSEN 10289, meets to the characteristics of the holiday detection without any problem at 15 kilovolts. Now, I want to narrate something else. If you look at the specification NES SP0188, it talks about the holiday detection, high voltage holiday detection. Now, when you see the liquid applied coatings, the maximum uh, voltage rating given for the thickness of 1500 volts, 1500 microns is 6 kVA. And in case of BSEN 10289, it is at 1500, 15,000 kilovolts. 6,000, 15,000. So uh, that's why I proudly take opportunity to share the PQT which was carried out. Here it says that as per the specification, it has to be checked at 6 kV, checked at 15 kV, and no holiday found. And the coating was absolutely intact. This is what the coating is giving. It is giving highest performance, highest insulation. It plays a very good barrier. It is giving a very high resistance to the cathodic disbondment. It gives a very good resistance to any kind of corrosion elements to pass through. Then uh, people will say that why this coating is performing. Is it performing only onto the good prepared surface? My answer would be yes, it is performing onto the good prepared surface as well as it is performing onto the pitted surface also. This pipeline is from NTEPCL at Chennai, and this was coated with our Pentazone 1000 BSEN 10289. It was coated in the year 2018, and recently, very recently, again the corrosion audit was carried out by me, and we found each and every pipeline is 100% intact. The atmospheric condition here is CX, that is C. It is more than C5M, that is CX, C extreme as per ISO 12944 part 2 environmental classification, and it is performing in this area very uh, very very good performance in this particular area. So people says that why you are insisting on to the epoxies and not the PU. for BSEN 10289? The answer for this would be epoxies can give you the highest bonding, more than 2500 psi. It can be made internally flexibilized. Okay, you can modify epoxy and make it internally flexibilized. You can't modify polyurethanes and make it internally hard. No way. It's impossible to make polyurethanes hard coatings than that of the showed the hardness of more than 70. Okay, you can you can have the greater flexibility in application. That is, you can apply it by brush, you can apply by single lick airless, you can apply by plural component. You have lot of choice. You get the hardness above 80 surety. You get a very high cross-linking density, which gives you in turn a very high corrosion resistance as well as temperature resistance. In case of polyurethanes, the cross-linking density is very less, and that's the reason it fails as the temperature increase takes place. So most suitable coating in the Indian climatic condition, because it has got a high pot life. The pot life is almost 15, almost 30 minutes at 40 degrees C, which is a huge pot life, and in which you will be able to cover most of the pipelines. Okay. Uh, as far as polyurethane is concerned, as you go on increasing its hardness, its pot life goes shorter, shorter, shorter. It could be something like 60 to 90 seconds when it gives you the hardness of say 70 surety. But it typically, when you decrease the pot life, what happens here, it decreases the surface wetting, and that's the reason you will get the lower adhesion to the substrate. And that's the reason I always say that uh, BSEN 10289 kind of a material, or most of the uh, pipeline external material, should be made of epoxies and not that of the polyurethanes. Uh, that is the one constraint. And let's talk about how the Pentazone 1000, what is the technology behind it. The technology behind it is the moisture displacement technology. Moisture displacement technology, if I want to explain it to the layman, I would say that if you have oil on your hands, what do you do? If you want to wash it with the water, you will not be able to wash it with the water if the oil is on your hand. So what you do, you take a soap. You take a soap, apply it on your hands. Your hand will be able to get washed off with the slight amount of water, slight amount of soap and slight amount of water. You will be able to wash it off. Now, why you will be able to wash it off? Because the water will be able to wet your hand properly. With oil, it will not be able to wet it. In similar cases, what is going to happen, if the water is there onto the surface, coating will not be able to wet the surface. So what do we do here? We add additive, which is moisture displacement from the substrate. Okay. That particular additive reacts with the surface and displaces the water from the substrate. I think if I explain you with the slide may not give you the correct understanding. Let's have a look at how it displaces moisture and get it applied onto the surface. Okay, so you can see here, I'm applying this coating in seawater. There is abundance of water, and in this water I'm able to reach through reach to the substrate with the help of a plural component equipment, and I'm able to apply a coating very easily without any problem onto the substrate, even though the whole lot of water is present, and that too seawater is present. Now just tell me, if it can get it, if it can coat in the seawater, then it can coat any substrate anywhere. And that's the reason we say that our coating can be, I'm not saying that it should be, but I will say that can be giving you a very good adhesion onto the surfaces which are power tool clean. I will explain which power tools that you need to have. So the technology here is, yes, it has got the epoxy resin in it. Okay, it has got a carbonyl glycerol in it, and a very special additive which is going to take care of the surface, along with a curing agent which is based on phenolkimine, a special blend of a moisture displacement agent, and uh, giving a highest adhesion to the coating uh, uh, with the help of those curing agents. Okay? Why we say that our coating is suitable with the power tool cleaning? We recommend a power tool cleaning with such type of power tools, such as hammers, scarifiers, non-woven abrasive wheels. Yes, it can clean the surface and can create a good profile depth, along with the bristle blaster. Okay, along with the bristle blaster, you can get you can get very good surfaces that can be taken care for the services up to say 20 years, 25 years of a service expectation. Now, this bristle blast can give you a clean surface as well as the ankle pattern. Okay, so that is more than enough for us. Okay, so I would say, what are the great features with BSEN 10289? That is Pentazone 1000, BSEN 10289. It has got absolutely zero VOC. It is solventless. It is made as per BSEN 10289. It is extensively tested and approved by the recognized worldwide standard. It is suitable for application by any type of equipment. It can be applied by brush, it can be applied by single leg airless, it can be applied by plural component airless. It has got a single coat applicability, so it is almost reducing the installation cost. Okay, it can be applied onto the power tool cleaned surfaces, and when I'm saying power tool cleaned surfaces, I would say that it should be prepared to SSPC SP 15 at least, with some profile, so you will get a proper adhesion. And why we say that this is very suitable, because it is extensively tested in our lab with EIS. EIS is a fast, non-destructive analyst, uh, uh, a, a method which can give the pre-qualification of the coating system, various corrosion protection classes. So it is going to give you the results in RC, YO, and the N value, which is going to represent the water ingress. So when we talk about this, the first and most important thing which comes to your mind is, what is that is going to give you the conditions after testing with EIS. So let's have the interpretation here. Uh, if the RC is greater than 10 raised to 8 ohms per centimeter square, uh, then it is going to be a good protection. Okay? If it is 10 raised to 7 to 10 raised to 8 ohms per square centimeter, it is standard protection. If it is going to go below 10 raised to 6 ohms per square centimeter, then it is going to be a poor surface protection, corrosion protection. Now, here are the uh, list we have got. We have got RC value of 7.59 into 10 raised to 8 ohm square meters, square centimeters, which is absolutely very high. And value is 0.9, which is ideal if you are considering to be a material which is exposed to the soil. Okay, for the soil corrosion, it is one of the best value. It has got a relative water intake which is less than 0.1 micrograms. It is in the micrograms now, micrograms per centimeter square. So it is going to give you the best performance. So I would like to say that much for your attention. BSEN 10289 is one of the best development that is carried out by Grauer and Weil, and it is going for the protection of field joints, can take care of field joints not less than 15 to 25 years of life expectancy. When I'm saying this 15 to 25 years of life expectancy, 15 years when you have applied it onto the hand tool, power tool, clear, sub, hand tool, power tool, clean substrate, and 25 years when it is applied onto the blast plane surface. So thank you very much. Thank you for your attention.